All right, so a composition of function basically just means that we're taking something and we're putting it inside of another function. It might be a number, it might be an x, it might be another totally different function like x plus 2, or it might be a quadratic, x squared plus 4x minus 1. So you kind of need to understand the notation first. You guys remember seeing this weird like fog? It looks like fog. It's really this. This is the way we typically write it. Now, the reason I show you both is the ACT will write it one way, you'll see it one way in a textbook. It's written different ways depending on where you go. So you need to kind of understand both. But both of them, we say it like this. F of g of x. Now I think of it as like one function is like hugging the other one. So this one is f of g. So which one is on the inside? G. F is like the main function, and F is hugging G. But it can also go backwards. So G, O, F of X is really written like this, with G on the outside. And then that means F is being plugged into G. And the way we say that is G of F of X. And it kind of tells you in the bold, that means the F function is plugged into the G function. Okay, so I'm going to go to number 5 first, actually. I'm going to skip around here. So go to number 5. We have two functions here. One of them is f. I'll do that one in red. And one of them is g. I'll do this one in blue. So what is this asking me to do? Now notice that's not an O. It's not an of sign. That's a plus sign. So this is I want to show you both. Because this is what we just talked about. We'll get to that in a second. But this, I think this is actually even easier. This just tells you, it wants you to take the f function and add the g function. It's just telling you to add them together. It's a weird way of saying that. So f plus g of x is equal to the f function plus the g function. So what does it mean to compose something in art class? What are you doing if you're composing something? Hey, you're like putting stuff together. You're paper mache and you sprinkle some glitter on top. So we're taking functions and we're putting them together. We're composing them. So what does this simplify out to? Red and blue makes 2x plus x is 3x's, and then negative 1 plus 4 is positive 3. Now that is your answer. That is f plus g of x. Now in a way, remember f of something, that's talking about your y values, your outputs. So really, this is kind of like y equals 3x plus 3. It's really just a line. We took a line, we added another line to it, and we got a line. So what is the y-intercept of this line? Because now it wants us to graph what we just found. Yeah, it's 3. It's that b value. So on your graph, you'll put a 3. And the slope, so this is y equals mx plus b. What's the slope? Here's your slope. It's also 3. So what does that mean? 3 over 1. So rise 3, run 1, rise 3. You can go down 3, left 1. I do it as many times as you can. So that is f plus g of x. But now, I wanted you to see these side by side, the difference. Now we're composing one of the other. So I would first rewrite this as f of g of x. So what's on the inside? G. So we're going to take the g function, and it's inside of the f function. So we're going to take whatever g is, and we're going to plug it in to the f function for x. Okay? So, first of all, I'm going to start out with the main function here, which is f. So what is the first thing in the f function? A 2x. But instead of an x, I'm going to write the g function. So we have to take the g function and we're plugging it into the f function for x. So anytime I see an x, I'm going to write x plus 4. But then you have to write the rest of the original function. So it's 2 times x, but then there's also a minus 1 out back. That was a part of the original f function. So instead of 2x minus 1, it's 2 times the g function minus 1. So now we'll distribute through. Minus 1 out back. So what's our final answer? 2x plus 7. Now they could ask you to graph that. What's the y-intercept of that? 7 with a slope of 2 over 1. So this is kind of like the easiest way of composing functions is taking a constant, the number 2, and evaluating the f function at the constant of 2. So in other words, we're going to plug it in. That's all. That's a fancy way of saying plug it in. So f of 2 is equal to. Now I'm going to write the f function, but anytime I see an x, I'm going to write the number 2. And it actually happens twice because it also ends with a 3 times 2. So I wrote 2x squared minus 3x, but instead of x, I wrote the 2. Now this is where people will mental math wrong. So on this test, you really need to remember our orders of operations, PEMDAS. What do we have to do first here? Yeah, a lot of people will do 2 times 2. And they'll do 4. And then they'll do 4 squared and get 16. But that's the wrong order of operations. What do I have to do first? The exponent. So we actually need to take 2 and square it first, which is what? 4 times 2 is 8, not 16. So if you don't do your good old PEMDAS, you're going to get the wrong answer here. And then sometimes people do 8 minus 3. They'll do 5 times 2, and they'll get 10. But what do I have to do now? Yeah, so after parentheses and exponents, we have to multiply. So this is actually 8 minus 6, which gives us a final answer of 2. Number 3, what's being plugged into what? X plus 3, I'll do it in blue. Yeah, it has to be plugged into the f function for all of the x's. So, I'm going to start out with f of x plus 3 equals, I'll call this one my red one. So 2, but as soon as I come across an x, you have to do x plus 3 squared minus 3 times x plus 3. We need to remember our order of operations. So what do I have to do first? Yeah, x plus 3 squared, which is x plus 3 times x plus 3. Which comes out to, if you FOIL that out, x squared plus 3x will give us 6x, and then 3 times 3 is 9. But that still has to be multiplied by 2. And then I'll go ahead and, as I write out this, I'm going to go ahead and distribute this through. So that becomes minus 3x minus 9. So don't forget that x plus 3 squared, which came out to x squared plus 6x plus 9, now needs to be multiplied by 2. So we need to distribute that 2 through that whole quadratic. Really, you should have a trail of equal signs to be mathematically correct. And now we can write our final answer. We just need to combine a few things. So we have 12x's and minus 3x's. So 9x's, and we have 18 minus 9. So that there would be your final answer. You need to find the domain of f of x. So we did these on our whiteboards. We did a lot of them like 2 or 3 classes ago. Domain is all of the x values that will work for that function. Now, what type of function is f of x? What do we call that? It's not a quadratic. It's not a line. It's not mx plus b. What do we call 1 over some x's, or x minus 2, or whatever it may be? It's a fraction. What word do we use for fraction? A rational function. What cannot be in the denominator of a rational function? 0. So what we did on our whiteboard is we took the denominator and we said, hey, denominator, you can't equal 0. Remember doing this on your whiteboards? So then we add 2 over what can x not equal? 2. Now, a lot of people remember that part pretty well, but you forget a majority of the answer because the domain is all of the x values that do work if I were to plug them into this problem. So what else does work? Everything else. So you need to also include all real numbers in your answer. It's everything but 2. Literally, 2 is the only number that will cause us to have a problem when plugging a number in for x. Now you could also write this in interval notation as negative infinity up to 2, but not including, or not including 2 to infinity. That's your interval notation of the same thing. I'm going to first write this as g of f of x. So what's being plugged into what? F is getting picked up and dropped into g. So I'm going to start by writing the g function, which is 3. But then, when I come across an x, I need to write the f of x function, which is 1 over x minus 2. And then you have to finish writing the g function, so make sure you write a minus 2 out back. So the way that we multiply fractions is straight across the numerator over straight across the denominator. So how do I subtract, technically, 2 fractions? This is 2 over 1. What do I have to have in order to subtract or add fractions? A common denominator. So I need to make sure that this fraction also has an x minus 2 in the denominator. So that will now give me 3 over x minus 2 minus, I'm going to distribute the numerator, so 2x minus 4 over, that is now an x minus 2. And now we just keep the common denominator, so our answer has an x minus 2 on the bottom, but we need to subtract across the numerators. So how many x's are on the first fraction on top? None. So this is kind of like 0x plus 3. So what is 0x's minus 2x's? Negative 2x's. You have to make sure that negative gets distributed to the 2x. And then I have 3 minus negative 4. It's positive 7. Good. So that is g of f of x. Find the domain of what you just found. So once again, it's going to be all real numbers, but x cannot equal what? Yeah, if I take this, 2 is the only number that will cause the denominator to be 0. What does it mean for this? What does this mean to do? Plug in 3 for all of the x's. So I'm going to do that first. Yeah, so we're going to set it equal to 146.